Okay, today we're going to continue on with 7-1. And I realized this handout I'm giving you today is the same thing that you have on the handout I gave you last time, except last time I didn't give you enough space. So we're going to talk about some of that, and you might want to refer over to the 7-1 today's handout. Oh yes, I will. I'll collect those if you guys want to get those ready. And I'll just average the two scores, and then I'll put that in as your S3 grade. Anyone else have a copy of 7-1 or some? All right, I'll go ahead and collect that test. Yeah, I got it. You have your. You don't have it. Anyone else? Your final will still replace your lowest test, but this will just average. So if it ends up being your lowest anyways, it will replace it. But hopefully you guys were able to make something click come the final.
I did.
Or maybe.
Like the first one?
Mm-hmm.
Didn't say inverse.
Yeah.
So that kind of
But do you remember? Yeah.
I mean,
Yeah, I know on the board I wrote it of the test, but you didn't remember that. And again, if it's an issue, when I give it back to you, we can consider it.
Where it was like, you give us 2 logs or 3, and then we had to figure out I can't figure that out.
You can't figure it out. You have to combine it into one on one side. Right? Log of A plus log of B would be log of A times B.
The equation, I just couldn't figure it out.
Get there. Well, and I'll grade these, give it back, and I'll post the answer key as well. Just coming in. You guys have your take-home part in thing 3. I'll take it. Okay, so last time we were talking about looking at eclipse that have been shifted. So, sorry, ellipse that have been shifted over by H and K. Keep in mind, everything stays the same. A is just the distance from the center to the major axis endpoint. So if the major axis is the X, then we're going to shift the center. We're going to we're going to move A units to the right and A units to the left, and we're going to find the major axis endpoints. The minor axis endpoints are always a B distance from the center. So if the center is at 0, 0, it's relatively easy to find. But if the center is shifted any, you just want to keep in mind all the Y components are going to be the same in this line, and all the X components are going to be the same on this line, right? And then the same thing, if the major axis is the Y-axis, the distance from the center to the major endpoint is A. So here we're just going up or down. All my Y components remain the same, and all my X components remain the same, and only my Y's change, right? If I go up, that's changing Y, but it doesn't change X at all. X is X doesn't move. Here, X is moving, but Y doesn't move. So we started to look at the example given here. and I didn't give you guys too much room. So the first thing we want to notice is the center, and the center is at 3 minus 2. So if I was to start to graph this, I might say 1, 2, 3, 1, 2. It kind of helps if I can use the same. Three, 2. Which is my major axis? Y. So that tells me I'm going to go up B units and down B units, right? So X is not changing. So if I need to go up, in this case, 5 units, I go 1, 2, 3, 4, 5. What's my new point? Yeah, 3, 3, right? Because it's 3 minus 2. So if I add 5 units to minus 2, I get 3, 3. The X doesn't change. You see that? So I also go down 5, right? 1, 2, 3, 4, 5. So what's this point? 3 minus 7, right? Minus 5 plus minus 2 is minus 7. Do you guys see that? That distance is A. This is A, because A is always larger than B. So the major axis is the y-axis, means it's parallel to the y-axis. So this distance is 5. What is going to be the distance on the minor axis? 4 units, right? Because B here is 4. So I go 1, 2, 3, 4. 1, 2, 3, 4. So what's this point's name? Very good. Minus 1, minus 2, right? The y component is not going to change on that line. So what's this point? So 4 plus 3, 7, and then the minus 2 doesn't change. You guys see that? So the last thing to find is the focal point. The focus points are always on the major axis, right? And the focus point is c squared is a squared minus b squared. So in this case, c squared is 25 minus 16, 9. So c would be plus or minus 3. So I go to my center, I go up 3. When I go to my center, I go down 3, right? Because my focus point's on my y-axis, or parallel to the y-axis. So if I do that, I go 1, 2, 3. 1, 2, 3. So what's this point? 3, 1. And this point? 3 minus 5. All right, you guys see that? So if I was to draw the shape, it's not wanting to draw. Okay. And then, of course, labeling my points. From the graph, I can get my points. The center is given, or the center is 3 minus 2. The vertices would be 3, 3, and 3 minus 7. The minor axis endpoints, minus 1, minus 2, and 7 minus 2. And the focus points are 3, 1, and 3 minus 5. You guys see that? So I want you guys to work on the second one. On that. What would be the center? Minus 1, 2. And you don't actually have to put a grid system on there. You can just say, okay, this is minus 1, 2. If I move to the right or left, my y is going to be the same. If I move up or down, my x is going to be the same. Sometimes I think it's a little easier to not have a coordinate system, because then I don't have to worry about it. I can just say, okay, all these are going to be x's too. All these are going to be, in this case, x's minus 1. And all these are going to be y's too. No, it's not. No, it's always on the major axis. The major axis is the x-axis here because 5 is right? So you're going to go 4 units to the right, 4 units to the left. It's not always the x. It's the larger one, yeah. So whatever A or B, A is always larger than B, but whatever the corresponding larger one is on the x-axis to the left.
What are those called?
C? C is the distance from the center to the focus point.
So it's
The focal point. So to the right, to the left, to the center, or up and down to the center, depending on your major axis. So you have your center, your vertices, which is always the endpoints of your major axis, the endpoints of your minor axis, and your focal point. So kind of summarizing this, we get A is 5 and B is 3. So I can plug that in the formula. C squared is A squared minus B squared to find C is 4. And then a lot of you spent, quite a bit of time writing a coordinate system. I think it's a good idea because then you can kind of check yourself. My y is always the same, or my x is always the same. This is x equals 3 or whatnot. You don't have to have a coordinate system though. Here, I kind of started this problem, and I didn't write in a coordinate system. I just have this is my center, this red point. If I go to the left or the right, since my x is my major axis, I go to the left 5 and I go to the right 5. So 1, 2, 3, 4, 5. My y stays the same and my x changes. So this would be 0, 1, 2, 3, 4. So this would be 4, comma 2. You guys see that? Or I could take 5 minus 1 and get 4. I could take 5, let's say 5 units to the right. This would be minus 1. I do that backwards. Yeah, so minus 1. I did it backwards, sorry. Minus 1. This would be 0, 1, 2, 3, 4. So this would be 4, 2. If I go to the left, I have minus 1, minus 2, minus 3, minus 4, minus 5, minus 6. So this is minus 6, 2. Do you guys see that? I can take 5 minus 1 and get 4. I can take 5 minus a minus 1. Sorry. Minus 1 plus 5 or minus 1 minus 5. If I go to the right, I'm adding. If I go to left, I'm subtracting. Right? Minus 1 minus 5 is a positive 4. Minus 1, minus 1 minus 5 is a minus 6. Minus 1 plus 5 is a positive 4. If you count the tick marks here and say, okay, this is minus 1, this is x equals 0, this is x1, x2, x3, x4. Right? This is x equals minus 1. If I go to the left, I have minus 2, minus 3, minus 4, minus 5, minus 6. So my x changed from minus 6 to minus 1 to 4, right? On my major axis. My minor axis, I'm going to go up and down. So if I look at what's underneath my y, the 3, so it means I go up 3 and down 3 from my center. So here, the only thing that's going to change is my y values. So I can go ahead and write my x values as a minus 1 and x down here is minus 1. So if I have a y equals 2 and I go up 3, I have minus 1, 5. And if y is 2 and I go down 3, I have minus 1. Yeah, right? 2, 1, 0, minus 1. So my x's stayed the same. You guys see that? So I got my vertices and I got my minor axis endpoints. And the only thing left is the focus point. So for the focus point, I know it's going to be on my major axis. So I know it's going to be parallel to the x-axis. And I calculate it to be 4. C is 4. So it tells me I'm 4 tick marks from the center. 1, 2, 3, 4. So this point is going to be minus 5 to 1, 2, 3, 4. This would be 3, 2. And a quick check here. Everything on this line should have a y component the same. Everything on this line should have an x component the same. You guys see that? So if I was to draw this figure,
Does it matter when you're like writing down points, like 96.2 or whichever one's first?
yeah, it doesn't matter. Probably what I'll have is I'll say, what are your vertices? And give you 2 spots to write them. It doesn't matter which one you write first. If you write 4, 2 and minus 6, 2 or minus 6, 2 and 4, 2, that's fine. Because there'll be 2 points for each one, except for the center. There's only 1 point for the center. You guys getting a little more comfortable with these? Know what A is, know what B is, know what C is. Find the center, and then you're just moving to the right or to the left, A units or B units. Up or down A units or B units, and the same thing with C, depending on your major or your minor axis. So usually A and B is is given. You can calculate C by knowing the formula C squared equals A squared minus B squared. And then drawing it, a lot of times I'm not going to give you points necessarily for drawing. I'm just going to give you points for knowing the center, the endpoints, the vertices, and the focal points. Question? No? So the next two examples, I didn't give you any space, so I gave you guys that handout. The 7-1 handout they gave you today, the front and back is these two questions. To complete these two questions, we're going to have to review completing the square. You guys remember completing the square? So we've talked a little bit about problems that are not in standard form, like this example. We had to divide through by 900 to get it in the standard form. Well, in the next two examples, we're going to have to do one more step to get it into standard form. Once it's in standard form, you apply the exact same things we've been talking about. So let's review completing the square. I'm going to go ahead and hop over to this view so we have a little bit extra room here. So let's look at completing the square. So if you recall, x squared plus bx do you guys remember seeing something like this? Every quadratic formula can be written. You can add to the left-hand side and add to the right-hand side to make it a perfect square. If you have x squared plus bx, you're going to add b over 2 quantity squared, right? If you add b over 2 quantity squared to the left-hand side, it's going to convert that just to b over 2, x plus b over 2 all together squared, right? So let's look at an example. X squared plus 2x. What do I need to add here to make it a perfect square? Right? I would add, and then I'm going to write this a little different, sorry. I'm going to add b over 2 and square it. In this case, that's 2 over 2 squared, which is 1, right? So that perfect square is x plus 1 quantity squared. This is the perfect square, and it is x plus 1. Yeah. What about if it was x squared minus 2x? Is it 1? Yeah, so it's 1 here, right? Because I go minus 2 over 2 quantity squared is still 1. But what is it on the other side here? Minus 1. It's always what's in parentheses. What's negative 2 over 2? Minus 1. Yeah, so minus 1, x minus 1 squared is x squared minus 2x plus 1. X plus 1 squared is x squared plus 2x plus 1. You can always complete the square to make it a perfect square. And you can always condense it. And it's always b over 2 squared put into the quadratic, but it's only b over 2 on this side. So let's look at this example above here. We're looking for, given this equation, write it in standard form. So the first thing I need to do is get all the x's together and all the y's together and everything else on the other side. So if I write this, I have 3x squared minus 28y. Oh, sorry. 3x squared minus 6x plus minus 7y squared minus 28y equals minus 10. Is it plus? Sorry. When I circled it, it looked like a minus. Sorry. So plus 6. Thank you. Is it a plus for the 7? I think so too. When I circled it, it went right through the plus. Okay, do you guys see what I did there? I just put I grouped the x's. So what I need to do here is I need to pull out the coefficient that's front of my x squared. So I have 3x squared plus 2x. And I'm going to leave a little space because I want that to be a perfect square. Plus 7x squared, y squared, minus 4y equals minus 10. Everyone with me at this point? So I want to make what I have highlighted here, I want to make that a perfect square. What do I need to add to this parentheses to make it a perfect square? Yeah, so I would put 2 over 2 squared, which would be 1. I added, you have to be really careful here because I have a 3 out in front, right? So really I added 3 to the left-hand side. Whatever I do to the left-hand side, I have to do to the right-hand side to keep it balanced.
Did you have to take the 3 out?
I did have to take the 3 out the way I submitted completing the square. If you left a 3 in there, it'd actually be over 2a. But if a is always 1, we can do it this way. If a is anything other than 1, and in this case, all these examples, you're always able to take out the coefficient in front of your squared term, whether it's an x squared or a y squared. Because whatever I do to the left-hand side, I have to do the right-hand side. I have to keep it balanced since I have an equal sign. So I added 1 in parentheses here, but it really wasn't 1. It was 1 times 3. This is 1 times 3, right? And then what do I need to add to this quadratic to get it to be a perfect square? Minus 4 over 2 squared, which is minus 2 squared, which is 4. You always add a positive number, right? So if I added 4 here, what did I really add? Yeah, so I have to add 28 to the right-hand side because that's 7 times 4. You see that? So now the next step is to write it as a perfect square. I have 3 times, what's this as a perfect square? X plus 1 squared, right? Because 2 over 2 is 1. Oh, and the next one would be plus 7 y minus 2 squared. You always add a positive number, but when you complete it to a square, you have to look at what's below in parentheses here. So this would be minus 4 over 2, which is minus 2. So that's where you drop down here. Equals, what's minus 10 plus 3 plus 28? 19? 21? So what do I need to do to get it into standard form? Divide through by 21. So here I have x plus 1 squared over 11 plus y plus 2 squared over 2 equals 1. Now I'm in standard form, and what is my center? What is my center here?
Is the y plus 2?
It should be minus 2.
Okay.
Yeah. Sorry. Y minus 2. So what's my center?
-1, 2.
Minus 1, 2, right? And my a here is the square root of 11, and my b is the square root of 2. Not too fun, but not impossible to deal with. So my major axis, this, I don't know. What is 3 divided by 21? Don't know. 7's kind of like 11. They're both prime. Sorry, guys. 7. And this is 3. 3 over 7. Oh, I know how I got it. Because on the next example, the answer is 11. Plus. This is 3. The next example is 11 and 2. But so your major axis is still your x-axis. The distance from your center to your vertices is just going to be the square root of 7, which is a little annoying because it's kind of hard to count tick marks over. So one way you can write it, so we know we were given here the center is -1, 2. My major axis is my x-axis. So if I want to find this point and this point, it's going to be -1 plus the square root of 7. And this is -1 minus the square root of 7. You can just write it like that. You don't have to. Right? And then the same thing here is square root of 3. So that's the x component. The y component remains the same because we're looking at a point. This is going to be -1, 2 plus the square root of 3. And this is going to be -1, 2, sorry. This would be 2 minus the square root of 3. And the other one's 2 plus the square root of 3. So you guys see that? If a is the square root of 7, just treat it as any other number.
What if I did put it to this? Could I still do that?
On Alex, I think that it says exact answer. So they'll say, what is the vertex? And you would say -1 minus the square root of 7, comma 2, and -1 plus the square root of 7, comma 2. If you put it in a decimal, just kind of approximate it. If I see it's square root of 7, that's fine. And then your focus point will be on your x-axis, and you're still going to take a is the square root of 7, b is the square root of 3. So c squared is a squared minus b squared. So that's 7 minus 3, which is 4. So c here, right? So c would be 2. So it's going to be this and this. 2 units to the left and 2 units to the right. So here, this would be -3, comma 2, and this would be 1, 2. Right? And you can kind of check yourself by looking at this way. 2, 2, 2, 2, 2. All my y components are the same, and I always stay on that y component. And all my x components, -1, -1, -1, they're the same. Only my y is changing. Now you guys work on the next one. Last couple minutes of class here. First thing you want to do is group the x's, group the y's, pull out the coefficient in front of the x squared and the coefficient in front of the y squared. Add that number in to make it a perfect square. Whatever you do the left-hand side, you have to do the right-hand side. Remember your coefficients out in front of the parentheses.
You can always get to me as I forget to subtract the 40.
Yeah, you have to be careful here because you want to put the 40 on the other side. Right. So we have pull out a 2. I have x squared minus 6x. So does anyone have any questions on setting up the equation like this? See where all that came from? Didn't get probably. The sign-in sheet go around. Did everyone have a chance to sign in? And you just get it. Can you pass it behind you? So what do I need to add in to this group to make it a perfect square? Minus 6 over 2 quantity squared, which is minus 3 quantity squared. So I add 9 in here. When I do that on the left-hand side, I'm really adding 2 times 9, right? So I need to add 18 to the other side. So by adding in 9, that makes this a perfect square as x minus 3 quantity squared. Do you guys see? This minus 3 is where this minus 3 comes from. What do I add to my y quadratic to make it a perfect square? 4 over 2 squared. So that's 2 squared, which would be 4, right? So I add 4, but really I'm adding 44 because that 11 out front. So I have to add 44 to the right-hand side, and then I can write that as 11 divided by y plus 2 quantity squared. So that gives me 22. 44 minus 40 plus 18. So what is my last step here to get it into true standard form? I divide everything by 22, right? So 2 divided by 22 is 11 plus, sorry, 2 divided by 22 is 1/11. 11 divided by 22 is 1/2. And 22 over 22 is 1. So now that I got it in standard form, I can then find my center, which would be 3 minus 2. So if I come out here, this point is 3 comma minus 2. Three comma minus 2. Zoomed in on one. What is my major axis? The x-axis. So I'm a distance from square root 11. My minor axis, I'm a distance to square root of 2. My focus point is always going to be c squared is a squared minus b squared. So c squared is 11 minus 2. So c in this case would be 3. So I go to the left 3 and to the right 3. On this next exam, I'll probably break up 7-1 into here's in standard form. Can you tell me the focus, the center, the vertex, the endpoints? And then I might say, okay, you need to put this in standard form. Granted, once you get into standard form, it reverts back to a problem of here's a standard form. Find me those 4 interesting points. Any questions on completing the square or putting it into standard form? Jumping back to the notes, we're going to talk about 2 more things. One of them is I can give you information about the figure and you can come up with the standard formula for it. So this example, I give you the vertices and the focal points, and I have you come up with the general form. So recall the general form is x minus h squared over a squared plus y minus k squared over b squared equals 1, depending if A and B major and minor axis. Here it tells you the vertices, the y doesn't change, so it's parallel to the x-axis, so you know the major axis that A here is actually under the x squared. But if you switch A and B, that's fine as long as the major axis is under the larger one, right? Doesn't matter if you call it A or B. If you want to be consistent, you know that c squared is a squared minus b squared, and just know that it can't be negative. So you take the large one minus the smaller one. Here, it doesn't give me the center, but it tells me this point is 4, 2, and this point is minus 4, 2. Sorry, I switched them. Minus 4, 2, and 4, 2. So I know halfway between these points is the center. Halfway between the vertices is the center. Right? Halfway between the endpoints is also going to be the center, but this turns out it's going to give me the answer of A. So what point is halfway between minus 4, 2 and 4, 2? 0, 2, right? So my center is at 0, 2. My A value, what is my A value? 4. The focal points are given as square root of 15, 2 and minus square root of 15, 2. So if I put them here, this distance, red, blue, this distance tells me C, right? Which is square root of 15. This is square root of 15, comma 2. This is minus square root of 15, comma 2. That tells me the C distance is the square root of 15, right? So what is H here? Is the shift in the X, right? From the center. Do I shift X any? So H is 0. What is K? minus 2. Yeah, since k is written as y minus k here is actually only 2, right? But I'll have y minus 2 when I plug it in. You guys see that? This is y minus k. If k is 2, y minus 2 would make a shift of 2. What is A is given, or A I calculated as 4. So C was given or calculated as square root of 15. So finding C, I use this formula A squared minus B squared. So I have 15 equals 16 minus B squared. So here B is 1, right? 4 squared A. So I have B is 1, A is 4, K is 2, and H is 0. So plugging in that standard form, I have X squared divided by 16 plus Y minus 2 squared over 1 equals 1. So you see that? Given the information, I can find what A is, find what C is, use that formula to find B, and then H and K from the center point, and get the general form. So next time, the very last thing we'll talk about is this C value in century, and it has to do with how circular is the shape. So C that is closer to 0 is going to have a more circular shape than a C that's closer to the 1. And it's always E is C over A. Sorry, not C, E. E is the notation, and you take the ratio of C over A. So in this case, A and C were given or calculated, and we get 4/5. In this case, A and C are calculated, and we get 2/5. And you can see this shape's much more circular than this shape. I will see you guys on Friday. I do. You can look at it, but you